I got this contact secondhand information from Ben, so I'm going to pass the mic to Ben. Maybe give us a little bit more impetus on how this happened. But tonight we've got Jacob Boxerman, A2AE. So you tell me, my friend, how is this? How did this go down?
Yeah, so Jacob KE2CZX, who that is a sort of a mouthful of a call sign, is my first cousin. So that's how I know him. He's a student at Columbia University. I think he's a rising senior. Yeah, he's nodding. So probably that's correct. In his free time, he's a member of the Columbia Space Initiative, where they do all sorts of fun things, including high altitude balloons. You may or may not remember his paragraphs article, I think from last year, where he described some of this. I think he's going to go into some of that and also going to give us some history about Columbia's amateur radio programs.
Hey, without further ado, Jacob, take it away.
Hi.
All right. He's back
All
and we
right,
can.
I'm here. I'm sorry I couldn't come in person. I'm currently outside Los Angeles, but I am planning to come out, and I'll definitely align my trip to a Friday evening so I can come stop by and say hello to everyone in person. But until then, I hope everyone enjoys my presentation over Zoom. I'm going to be discussing amateur radio at Columbia University, history to present day. So I'll spend some time discussing the deep and rich history of amateur radio at Columbia. And then I'll discuss a little bit of my work trying to revive amateur radio at Columbia and engage more students both with the hobby and also the technical aspects to grow our technical capabilities and become people that have skills that not a lot of other people have. And I'll have some time for questions at the end, obviously, and stop me if there's any problems with audio or the slides or anything like that. And yeah, Ben covered everything in the introduction. I will be a senior next semester in the fall, and I'm studying computer science. But I enjoy hobbyist electronics. It helps get me away from my screen and interact with sort of another side of the science. We'll go over a brief introduction. We'll talk about the founding of W2AEE, which is the call sign that we have for our shack. We'll discuss some interesting facts and history, and then we'll talk about the Columbia Space Initiative. Now, the early beginnings of the Columbia University Amateur Radio Club, it's really a subject of historical debate due to the scarce records from its earliest days. But the evidence suggests that the Columbia University Experimental Wireless Station was established around 1906, possibly in Chandler Hall or Havermeyer Hall, which were some of the earliest buildings at Columbia University, whose Morningside campus was constructed around 1898. So this was a very early venture in the history of Columbia as it relates to their new campus. And then there's the Wireless Telegraph Club of Columbia University, which was actually certainly documented by the New York Sun in an article from November 1908. And that article highlights some of the early activities of the club, including the setup of communication between Havermeyer and the University Hall, and the involvement of some prominent professors who were instrumental in the early days of radio technology, which we'll discuss. This is the engineering building that you can see on the right in this picture. The campus looks very different today, but this building still stands, but it's a different function. Unfortunately, it's no longer engineering. Here's an article detailing the one I just mentioned, the Wireless Club at Columbia, from the Sun. And it has a great quote. There was a bit of a contention between the Aero Club and the Wireless Club. And I'll just read out a tiny bit of the article for those of you who might not be able to see it. It says, the Aero Club, which the students of Columbia University formed some time back, is not to have an absolute monopoly of the air, hot and otherwise, on Morningside Heights. A rival appeared yesterday. And it goes on to discuss how the founder of the Aero Club, it says here, Grover Cleveland Loaning, the father of the Aero Club, said, "What in the blazes is that?" as he saw students stringing up wires and seemed to be in a fuss all about that. So it was a very momentous occasion when radio became sort of an idea for students at the university, not just as sort of a research topic for professors. Now, the early call sign was not W2AEE, and I'm sure many of you are very up to date or back to date on this sort of trivia. But the early call sign was actually 2XM. That was the original identity. So in 1913, under the Radio Act of 1912, the club was assigned 2XM with a professor, John Moorcroft, as the control operator. At that point, they coasted along for about 10 years until they were reassigned in 1925, and the club was issued 2FK. And then finally, around 1931, under the rules of the new FCC, the new FRC, the Federal Radio Commission, which no longer exists, the club adopted W2AEE, and the call sign remained when the FCC replaced the FRC just a few years later in 1934. And around that time, actually in the 1920s, the station relocated into the attic of the engineering building, which, as I mentioned today, is the mathematics building. And on the right here is a booklet dated to 1931, listing all of the amateur radio stations, and of course, the Columbia Radio Club is listed in the book. Let's see, and here's one of these beautiful cards here, found in 1913, 2XM. And the specification was designated as a special class experimental station. So the designation was originally 3 items, as you can see on the bottom. There was the number of the district, followed by 2 letters of the alphabet, with X standing for experiment, Y for technical, and Z for special amateur stations. So as an experimental station, Columbia University, with Professor Moorcroft as the operator, was assigned to XM. Okay, and if you're curious, later actually 2XM was reassigned to another station in upstate New York, interestingly. And here are some of the beautiful cards throughout the days. So the call sign W2AEE, which is what we know and recognize today, was listed as early as 1931, and it was solidified by the Communications Act of 1934 by the FCC. So that has been the case since then. So a few call signs have gone in and out, but W2AEE is likely here to stay. Here's a card. Here's another. This one is from 1953. The designs have seemed to change a lot in the 50s, and they've become pretty solid since then. I think some of these ones from the 50s are particularly beautiful. I love the design. Clearly, a lot of time and effort went into producing these. This is 1953. We have 1959, the voice of the roaring lion. You can see the lion, the Columbia's mascot, on the left, and on the right, Columbia University's School of Engineering. So the radio club was distinctly associated with the School of Engineering as opposed to other schools, which is actually something that changed shortly, which I'll get into in a little bit. Here's a card from the 70s. This picture is a view of the skyline looking south on Manhattan. Now that brings us to another question: is how old? What claims can the Columbia make about being particularly old? Now, among amateur radio clubs, there is a notable and a spirited rivalry between W2AEE and MIT's W1MX for the distinction of America's oldest college amateur station. And it's not much of a heated debate, as it has been going on for the last, let's see, about 80 years or so now. So things have mellowed out. However, there has been debate MIT claims a founding date of April 30th, 1909. However, Columbia possesses documented evidence from the Sun, as we discussed earlier, dating to November 1908, which actually predates MIT's claim, and some further anecdotal evidence even suggests operations as early as 1906. However, perhaps it's up to the rest of us to decide how we would actually designate who is the oldest amateur station. When call signs change, when themes change, when interests change, is it the same station? That's up for us to decide. And this contest has played out in the official in QST from the ARRL with letters to the editor. You can look back when different pieces of news have been rediscovered by different club members trying to boost their pride. And this is a great example of the deep historical pride within the amateur radio community. I mean, look at the club right now. Look at the PARA dating back to 1937. That's a heritage that not a lot of clubs around today can actually claim. And that brings us to the evolution of the radio club. The 1930s was a very interesting time for radio, both at the university and in general. The 1930s saw the club focus on FM promotion and demonstrations. Major Edwin Howard Armstrong, who I'm sure you're familiar with, who created FM radio as well as a number of other technologies. He was a big booster of FM radio, of course, as his invention, and the university and students decided to join in on that effort. On the right is a great picture of E.H. Armstrong suspended from a radio tower in Alpine, New Jersey, across the water. And Columbia University's radio club or radio station, student-run radio station, has been deeply interwoven with W2AEE's history. The Columbia University Radio Club, or CURC, which was active by 1936, was originally fundamentally a technical club, which was immersed in the nuances of radio communications, especially because of the influence of E.H. Armstrong. But as membership swelled, the interests of the students diversified, and they became interested in creating a broadcasting platform for the campus community. And that's a platform that's continued to this day and has been involved in a number of historic moments at the university. Now, the ambition, of course, was shaped by E.H. Armstrong, who was arguably the most prolific inventor in radio history, most famously inventing FM radio, as I said, also the super heterodyne receivers, regenerative circuits. He provided a very important influence for radio innovation at Columbia University. Now, Armstrong actually helped students in their early efforts, where he donated a microphone and turntables when they designed their first makeshift studio in a dorm room which still exists to this day, but likely most students have no idea of the historical significance there. Now, today, the station is known as WKCR. Now, his generosity, of course, played a crucial role as he donated equipment to get started. And the club, early in the late 1930s, the club was heavily involved in promoting the FM technology, even before it became very widespread. They wanted to promote the use of FM, they wanted to demonstrate its effectiveness and its advantages. After that, by 1939 and 1940, under the leadership of Bill Hutchins, the club organized a campus radio station, making the move from purely experimental to attempting to provide some sort of service to the community. Technically, they were operating as an illegal carrier under the FCC regulations at the time. CURC, as they were known, they broadcast at about 260 on AM. And remarkably, the club members actually designed and built the transmitter from scratch, and that laid the groundwork for what is now WKCR. There's a picture on the right here This is a picture from the demonstrations at Columbia University in 1968. And that's particularly notable because there were a number of demonstrations, as I'm sure you've all heard on the news, in about a year ago, so in 2024. And WKCR has continued their tradition of trying to provide important news services to the members and the community of the university. So you can see there are two operators broadcasting. They have their telephone, they have some broadcast equipment, and there's students protesting right across from them. Now today, the students who run WKCR mostly use, or almost exclusively will use digital equipment, cell phones to do their recordings. But this is an excellent picture and demonstrates sort of that continuity that exists throughout the hobby. Another excellent fact is relating to W2AE's critical role in tracking Sputnik 1 in October of 1957. So Sputnik 1 was launched by the Soviet Union on October 4th, 1957, marked the dawn of the space age and the start of the space race. It transmitted a simple beep. It was like a 3-beep signal on 20 and 40 megahertz, and it was just the beacon of this new era. And official tracking stations were being, assembled to actually track Sputnik from the United States. But W2AE was at the forefront of the effort to actually successfully track Sputnik. Using their shortwave radio station, the operators recorded the satellite's distinctive signal beep on tape, and they took that tape from the station, from the shortwave station, and broadcast it over WKCR. And this became, an excellent story for the club. And I'll just read a quote that I have from one of the members of the club at the time. He said that clearly someone was listening to WKCR even in those 10-watt days. The next morning at about 9:05 a.m., 2 men walked into the station and flipped badges showing they were from the FBI. "We understand you have a tape of that Russian thing out in space," one said. "Oh yes, everyone at the station burbled proudly since we were the first radio station in the USA to get it on air." The FBI men then stole the tape. I say stole because they never returned it, paid for it, or replaced it. And this monumental achievement by the club was recognized in a feature in the university newspaper, the Columbia Daily Spectator, in April 1959. This brings me to amateur TV, continuing the idea of pioneering technologies to use for communication and sharing, as a lot of us, have an interest in that in the hobby, and especially one can see why that might appeal to college students. Now, beyond voice and CW, W2AE consistently explored new modes of communication like amateur television. In 1959, CURC conducted a remarkable feat, which is a live telecast of the historic Child's Cup Regatta on the Harlem River. Using their experimental equipment, they transmitted video from the race course, which were then received and displayed on monitors in a lounge in the dorm, as well as at the regatta's finish line. And you can see a picture of the camera setup and of the displays on the right over here, overlooking the river. And I'll show some more of these beautiful color photos, trying to get the camera set up. Apparently, it was quite an effort to get all this put together. Here's another picture of the regatta happening on the river, and this was about 1959. Now, the history starts to change a little bit. The 1960s ushered in a period of ambitious expansion for the club. So there's an article from around the time which detailed their plans for a very substantial upgrade to the station infrastructure. And the goal was worldwide communication over HF. And it was overseen by Professor John Bowes, who was a former student and associate of E.H. Armstrong. And he tried to maintain sort of the status and the progress that the university and the students at the club had been making over the past almost 5 decades at this point. The centerpiece of this expansion was the construction of a steel tower, and the tower was engineered to support a complex array of antenna systems, some Yagi antennas, several long wire antennas, and attention was also paid to the infrastructure. So they built dedicated conduit for antenna lead-in lines to minimize signal loss. It was an attempt when the new engineering building was built to put radio at its core and to ensure that the infrastructure would be there for the future. And the club also undertook a significant project to build a high power amplifier using repurposed components. That seemed to be always have been a concern, was trying to repurpose things and keep their budget as low as possible. So they wanted to increase their output power from 140 watts to what was then the legal limit of 1,000 watts, and that would have provided a very significant power boost. And that really epitomizes the ham spirit of building and optimizing equipment and taking what they already had and improving it. Just a little bit more of this information until we get to the current status, because it seems important to me. This completion was actually celebrated by the dean of the university, or of the college, who made the symbolic final connection between the equipment and the antennas. And that support was very important for such a large-scale project. And the club's new station was on the 14th floor, where it still is today, of Sealy Mudd Hall, which provides excellent elevation for antenna performance. From the top, you almost have a view of the entire skyline, much higher than any other buildings in the area. And a dedicated shack was built. And so the initial antenna array has a Yagi antenna for 2 meter for VHF, as well as an antenna to operate on 10, 15, and 20 meters. And there's like 150 feet of wiring down from the top to the shack. And there are future plans, including rotating equipment, which was eventually installed to point signals in any direction without having to go up for physical access. Now, what is the current status of the club, of W2AEE? So bringing it to the present, the club remains an element of the amateur radio landscape, although membership has fallen significantly since its peak in the 1960s. Now, a key contribution is there's a APRS digipeater running, which is on the 2-meter antenna, and that's been running since 2001. There's an effort to get it assembled to provide packet relay during the 2001 New York Marathon. And W2AE also maintains a highly active VE, a volunteer examiner team, and they conduct, I think, monthly or every other month license exams, especially during COVID, as I'm sure many of you have also been involved with. And that's a testament to the continuity of the club. Members from many years ago have still continued to be involved. But there are also practical realities for the club. The existing VHF tower is in a state of disrepair. The HF tower is okay, but I believe the 2-meter might be having some problems. And the shack itself needs a significant cleanup. There's a lot of equipment that needs to be serviced, a lot of parts that need to be cleaned up. It's a very small space, and it's not conducive to having large meetings or large groups of people in. So that's work that needs to be done to try and bring W2AE into our decade right now. But however, there has been a revival in 2025 and 2024 of the club, and a lot of that has been due to new interests from members of the engineering school, students who want to use amateur radio for practical purposes. And it turns out that the best way to do that, as we know, of course, is to get your license as is required. And then from there, the whole world opens up. So it's open to some new worlds for some of us, which it has for me. And that brings me to the next section of my presentation, which is how I got into ham radio, why I did it, why I got into amateur radio, and how I'm bringing others into it as well. And that is with the Columbia Space Initiative, which is the largest engineering club on campus. We have over 400 members, and we have a variety of what we call missions, including rocketry, space microbiology. We build cube satellites, which are small 1-unit or 2-unit or 3-unit satellites. And we also do high altitude balloons, which is the team that I lead. And it is the place for practical ham at Columbia. It's really the place for any practical engineering, but is the place for practical ham at Columbia. And this is how I got this is what motivated me to get my license, because I saw somewhere I could use amateur radio. And I wondered, how can I, communicate over long distances, do some research? Well, radio is an excellent way. Turns out I need my license. Oh, I know many people who have done that. My cousin's done that. I thought I should do it for myself, and since then it has been a great journey for me. And I'm hoping to become even more involved in the future with more presentations like these, for example. So, high altitude balloons. What do we do? Our mission, we're a group of about 15 students, maybe 15 to 20 students. And we launch research devices on high altitude balloons. This is a very common ham hobby. This is something that a lot of hams do for a number of reasons. And it's an excellent experience for college engineers. I like to strike a line between doing something new and novel, and learning from the resources that currently exist. And for a lot of us, high altitude balloons, the skills required are not skills that are taught in class. And I've made it a priority to leverage high altitude balloons, to leverage having the resources from our club to expand our knowledge base. So here's a bit of the history. The Columbia Space Initiative actually started with high altitude balloons, and they started with ham radio. One of the members was a ham, and they tracked their balloon, as many hams do, with APRS, which I'll discuss in a minute. They had a few successful launches. You can see a picture from a successful launch. This is probably about 80,000 feet up. We have our mascot, Rory the lion, on the right. And unfortunately, the club sort of faltered during COVID, but it was revived by myself and another member in 2023. And since then, we've been trying to revive it, and I've been trying to place a focus on engineering and radio like never before. Here's a small clip I'll just play very briefly so you can get a sense. I'm certain many of you have heard about high altitude ballooning as a hobby, about pico ballooning, which I'll discuss in a minute. It's it's an excellent hobby. But the basic idea is to get a very large balloon and attach a number of research devices to it. And I'll show you what ours was. But here's a video of the team filling up their balloon. And then everyone has to put a camera on it, so you can get some great footage and see where the balloon goes. Now, it turns out we have to drive up very far to launch these balloons because number one, of airspace regulations, and number two, because of our proximity to the water, to the ocean. So it becomes a big challenge, a big technical challenge, and a big logistical challenge to actually execute these launches. So that's why we're trying to morph our theory to better, fit with our environment, and I'll discuss that in a minute. And it turns out that amateur radio has been an excellent way to do that. Go to the next slide. So the current status of the team, about 12 or 20 of us, 12 to 15 to 20 of us. Our members span computer science, mechanical engineering, astronomy, electrical engineering. And we attempt to come up with something interesting to expand on the basic concept of launching research devices on weather balloons. NASA does it, NOAA does it, many organizations do it, mainly for weather research. And it has to be something that fits within the scope of 1 to 2, maybe 3 semesters, so that all of our members can make impactful contributions that they'll get to see the fruits of. And another goal has been to revive our team's knowledge. Again, as I mentioned, the club died during the pandemic in 2020, and a lot of effort has been put into reviving that knowledge. So our first launch happened in March 2023. We launched a 1,600 gram balloon, and we had a styrofoam cooler payload. which we use for purposes of insulation. We had sensors, including VO2, volatile organic compounds. We had a UV. We had a acceleration, so a accelerometer, a gyro, temperature, as well as humidity. And we had internal temperature and external temperature. We also had GPS, and all of this was logging to an SD card. Additionally, once you launch the balloon, obviously most of the fun is getting it back. So we read that it's best to have two fallbacks, so it's like a satellite GPS and radio. One of the reasons for that is a lot of these satellite trackers will actually stop working above about 40,000 feet. And that's due to certain restrictions on, there's certain government restrictions on GPS modules. There are government restrictions, I'm sure many of you have heard of this, on basically the speed and altitude that consumer GPS modules can go. So for example, like a GPS module cannot move if it's moving more than, say, 200 miles per hour or above 40,000 feet, it shuts off. And most manufacturers simply disable that. And yeah, it's basically an ITAR, like a ICBM GPS modules. So most manufacturers will just cut off both. So what we had to do is build an APRS transmitter. Now, APRS is a digital packet radio. I'm sure many of you are familiar with it. And there's a huge network of APRS both out here in California and a lot in upstate New York. So we thought it'd be a perfect way to bring ham into the club. And this is what motivated me to get my amateur radio license, because of course, to be on 144.390, we need our license. So I studied, I took my exam on Zoom. I got my call sign. I'm Kilo Echo 2 Charlie Zulu X-ray. And then we began building an APRS position transmitter. And we wanted to go basically the simplest route possible, which ended up being a very strange creation. I'll show you, here's the sensors, I'll come back to that. It's a low budget because the first year of an organization existing, they don't like to give so much money when they're not sure they'll be successful. So we built an APRS transmitter with a Baofeng handheld transmitter that came with a microphone and an earpiece. And the microphone and the earpiece came with a push-to-talk button that would activate PTT on the HT. So what was the solution we came up with? The solution was to cut into the microphone and the earpiece that came with the transmitter, and basically use that as sort of a connection to connect it to a microcontroller. There were existing APRS solutions written in C or Arduino C, which would allow us to transmit over APRS to generate the modulation. So that's exactly what we did. It took a lot of experimentation, but we managed to control the HT with the cable it came with, and an Arduino. And these cables were, if you've ever cut into these are extremely thin. So this gave our team a great opportunity to actually get our hands dirty. These are a lot of students who have never had the opportunity to, look at work on real circuits that are for some practical purpose, to solder, to work on, install electrical connectors. So we did the best we could to give like a very solid engineering experience. So we did wiring by hand, but we worked on making it clean. We worked on using, traditional connectors. I think this is like a JST over here. And making the most robust and well-engineered system that we had the skill for. And this is a picture of this in my luggage on the way home from school for the winter. I was shocked I didn't get stopped by TSA for this micro Pelican case full of radio and sensors. And here's that other picture. So how did it go? This is an excellent lesson for all of us, I hope. The lesson is that full integration tests are key. Now, we had tested all of the pieces separately. We were up very late. I had a friend walking around the campus holding the box, the payload, with the handheld transmitter on, with the GPS module. and it was working beautifully. I have an SDR, and I connected it to my laptop, and I was watching those packets come in, and I was decoding the GPS location. I was decoding some additional, like some temperature packets that came along with it. It was working perfectly. So that felt great. We go out to the launch site, about 3 hours away, and we assembled the box, and we ran some initial tests, and things seemed okay, but we couldn't quite tell if the tracker was working. But basically, my guess was that once we got maybe a better signal, it would start working. I don't know what quite was going through my head. But as I mentioned before, we also had what's called a spot tracker. It's a company that sells location devices for tracking people, tracking assets. And we had the spot tracker suspended in the box with a string. We sort of made like almost like a suspension gimbal setup, because the box can land upside down. And we wanted to ensure that the device had a sky view, because the satellite connection requires the device to be have a view of the sky. So if it flips over, you're done. So what we did is we placed this GPS device directly above another GPS device. And if you know anything about GPS, which it turns out I don't, Spot in their documentation specifically states that you will have the best effectiveness at if you keep it at least 12 inches away from another GPS receiver, or from another transmitter. So yes, I did not know this, and we put everything together, and we launched the balloon away, and it slowly floated away, and we started driving towards the predicted landing location. And what happened? Well, we had no tracking information. We expected to start seeing APRS packets pinging, and we also expected to see the Spot GPS tracker sending out its locations onto their website. Neither of these happened. Looking back, it's simple to see why. At the moment, it was quite puzzling, and the theory was basically, we'd messed something up, and my expectation was that ideally the box would land in someone's backyard, maybe, and then it would be found. It would be found later. We put our phone number on it, and someone would call us. Well, I get home and I start doing research, and I find out that Spot has to be away from another GPS, and I realize that this is obviously the problem. So I ran the numbers, and I decided that if this was indeed a conflict, one of the devices would run out of battery first. So I investigated, and I ran the numbers on our power consumption on on the handheld transmitter, and the sensor setup, because it was all connected. We had 4 AA batteries or 6 AA batteries, and whatever it was, I ran the numbers, and I calculated that in roughly 18 hours, the first transmitter will die, and the second one is going to be able to start talking to us, and we would finally hear from it, and then we could go drive and pick it up. And that was my theory, and I didn't want to tell anyone, because I didn't want to create the false excitement or the false hope. So I put my number, I hedged my bets on 18 hours. The batteries are going to die. What happened? 18 hours later, I wake up, and I have a text from another member of the team who checked, and she said the tracker turned on. So I was right. The batteries died, and the conflict stopped, because the first GPS wasn't on. The handheld transmitter had stopped. The Arduino was dead, and just the Spot with its satellite tracking was working. Now, the shocking part, and this is a double lesson, of course, is we had a particularly windy day. And the fill of the balloon is extremely important, because that'll determine your ascent rate, how fast you will ascend to the burst altitude of the balloon, right? These balloons can go up to maybe 110, 120,000 feet maximum, depending on how much helium you fill them with on the ground. Turns out that we had underfilled the balloon because our measurements were off. We were off by about 1/5. Turns out to be maybe like 20, 30 cubic feet of helium. Probably if we had filled it for 1 minute longer, it would have risen much faster. The problem was it got carried out by the wind. So when the tracker finally died, and we got the first ping from the other tracker, the device was 250 miles off the coast of Newfoundland. And it amazingly said 40,000 feet altitude, 30,000 feet altitude. 5 minutes later, 20,000 feet altitude. 2 minutes later, 10,000 feet altitude, so on and so on. 500 feet above sea level. And then 0 feet above sea level, we got a ping, and it was never heard from again. So we lost the entire payload in the Atlantic Ocean, about 300 miles off the coast of Newfoundland. But my theory was correct that there was a conflict. So we learned a number of lessons today. One of them was to read the manuals of every device and to learn about mitigating interference, and also to properly fill your balloons so that it won't go into the ocean. It'll land on land. It'll go over land. So that was our first launch. It turned out to be a great story. And we tried again. So we did another launch and it went successfully, but we didn't put as much in it. We didn't put in the radio because we didn't put in all the sensors, because if we lost it again, we would have been kind of out of money. So we wanted to make sure we'd recover this time. And we did. We got the next one back, which is good. And that led us to realize that maybe we need a different project. Maybe we need something that's built to last a little longer and that's built to lose. So now we're building pico balloons, and I wrote a little bit about this in paragraphs. If any of you saw my article, I think it was in the January or February edition. And that's our project. It's a common ham project too. Pico balloons are ultralight trackers, which usually use WHISPR, or weak signal propagation reporter. You can download some software. I think it's called WHISPR XT, WHISPR XJ, something like that. It was written by I can send a link. It was Joe KJT, something like that. I'll send the information. I'm sure many of you are familiar, but it's on a number of different bands. We're looking at running it on 18 megahertz. Yes, K1JT. Thank you. We were looking at running it on 18 megahertz. With a very long, very thin antenna. These trackers are about 2 inches wide by about 4 inches tall, and they contain a GPS module, a very small sensor, and a computer to read the sensor, as well as solar panels to power the device. And they have usually an HF transmitter. So our project this semester has been designing our own pico balloon transmitters. It's a complex enough project for us, but there are enough online resources. Actually, I had some people reach out to me from my paragraphs article, sending suggestions, offering to send supplies, which I really appreciate. And it's a perfect project for new members to build skills, because it's very rare to be able to build and get manufactured your own small HF transmitter. It's very cool. So as a team leader, I think it's an excellent experience. It's an experience a lot of us don't get in a class. As you know, amateur radio is not at the top of a lot of students' lists these days. And I've been wanting to show that it's a resource that can prove to be a very fascinating and enjoyable hobby. And it also has some practical applications. And it's a cross-discipline project with an interesting result. So here's a picture of some of the members who have no experience with circuit design, no experience with RF, and we've built our own PCBs. Here's a picture of them. This on the left is the design from KeyCat, which is the software we used, and they were manufactured in China by a company called JLC PCB. Unfortunately, we did not have a chance to actually use them because they came right at the end of the semester, but they look excellent. They're built off of an RP2040, which is a very small computer. And we have an HF circuit with a low pass filter built in. And the wires, the antenna wires used on these are pretty incredible. People will go for a full 20-meter antenna with about 25 or 26 gauge magnet wire. It's the wire they used for winding like these very small motors. So we bought we have like 5,000 feet of wire that fits, in a spool that's like the size of my hand. So we'll be assembling these. We have to spool out, 30 feet of wire, or, like a dozen or, more than a dozen times, because we built 10 of these, and the goal is to launch many of them and see which ones can make it around. People have been able to circumnavigate the globe 6, 7, 8 times with these. And just like APRS, you can track anything. You can look up Whisper and you can put in call signs and you can see people's balloons. They're they're solar powered, as I mentioned. So they're very low energy. They transmit, Whisper is like once every minute or once every 2 minutes on the 2 seconds mark. It's very low power and only works during the daytime. So yeah, the current status will hopefully test and launch in September. And I'm now looking for more radio opportunities for myself and for the team. I think it's something that people have really taken to. And I'm looking for more ideas of more projects that we can do. The club still has sort of an aerospace focus, and that in certain ways limits what we can do. However, with some level of creativity, we can really do a lot of things. So we were going to build basically what's used for fox hunts. So we were going to build small beepers to transmit on maybe like 433 or something like that, and build some directional antennas so that we can have an easier time locating balloons if we ever launch those again. And that would be a great exercise in antenna design, antenna construction. And we have access to technology. Like we have access to 3D printers. We have access to wood shop, to a machine shop. So I'm trying to encourage our team and encourage myself to take advantage of the tools and of the education to utilize and take things outside of the classroom, and have like an interesting and useful result out of that. So that's the end of my presentation. I'm happy to take any questions. I'll do my best to answer them. And yeah, thank you. Thank you very much for your attention. I hope to come visit in person as soon as possible.
Thank you, Jacob. That was extremely informative. Question for you. I imagine in all your research with weather balloons, you've heard about the NOAA weather balloons that go up twice a day from various launch centers.
Yeah, the
Oh,
radio songs, yeah.
yeah, so we have a group of us out here that have nothing better to do than chase these. It's
I
just
know, I've been dying to do that.
it's just kind of fun because nothing else to do.
Yeah, no,
But
it's
but I
really,
know that some hams have been repurposing these radio songs when they get. I don't
yes.
know if that's something on your bucket list.
Yeah, it's really tough, like being where we are, the terrain. Our balloon actually got stuck in a 70-foot tree, and we had the most unfathomable luck. The tree that it got stuck in was in Stamford, Connecticut, and the owner of this property, a man and woman, happened to run a tree trimming business. So they trimmed their own tree with a 70-foot cherry picker, and we were able to get our balloon back. So if I have more time in California, that would definitely be, or somewhere more flat, that would definitely be a priority for me. I
Pretty
actually
cool.
bought this SDR recently, and it has a radio sound mode on it.
And I just looked up. It looks like the nearest one I saw at a glance for New York was out on Long Island.
Yeah.
And I just did the predictions are going east, so that makes it further. All right,
Yes.
cool. What we're going to do here is we'll take some questions in the room. Zoom people, if you've got questions, throw them up on chat, and then we'll get you. Anybody in the room got questions? Oh, Ben's got one, and then we'll head over this way. Oh, he's got a
Yeah,
mic.
so mine is going all the way back to the beginning of your presentation where you were talking about the original call signs under the Radio Act of 1912.
Yeah, I might not be able to answer very much. I only know what's related to the club, but please,
So
yeah.
the call signs were, you said it was a number, a letter, which is either X, Y, or Z, and then another letter. So that means there were only 700 possible call signs.
I suppose so. Yeah. I guess that's why they needed to. That was in 1913, and then by 1925 they reassigned, And then by about 1931, then they went to the longer name. So they didn't have many years to maintain. That was about 10 years. Yeah.
I think a lot of people in this room would like to get a 0x2 call sign if they could.
Okay. Oh, I got it. I got it. I got it. Here you go.
You mentioned a method of keeping the spot antenna upright in the box with strings, and the only thing that I can think of to do that is very expensive and very heavy. So if you could describe that to be helpful.
Yeah.
I did want to say you're not the only one to lose hardware into an ocean, so I feel better now because I'm not the only one that I know to lose hardware in an ocean.
Yeah, good. Welcome to the club. I wish I had a picture. We have like the tracking dots that just go over the ocean. It's so good. Um, okay, what was the method? Um, so we have some very clever mechanical engineer students who have this good perception with strings. They took a one long piece and they looped it onto every corner, and then they brought all of those to one point in the top and suspended it from the top of the box by about 2 inches or 3 inches. So what that would do is the gravity, the weight of the spot tracker pulls it down towards the ground. So when the box tilts, the cradle has like enough of a radius to turn such that when it's turned on its side, the spot will basically cradle itself down because it's pulled down by gravity, and it'll just weigh itself down, and then the top will be up. If I can dig up a picture, I can maybe send it.
Okay. Any other questions in the room? Oh, Shree's right behind me.
So with your Newfoundland experiment, you found out that you had two mistakes. And if both mistakes hadn't happened, you would never would have found the thing. In the case of your cherry picker, there was only one mistake. How do you choose the right number of mistakes in an experiment?
That's an excellent question. I don't think that's up to me to decide. That's part of being a student, I think, is making an infinite number of mistakes.
All right. Let's see. You guys at the Zoom desk want to answer some of the Zoom questions?
There aren't really any. I think the only one was maybe Jake. You didn't. You sort of alluded to the reason that they don't want you to have a GPS that goes very high or very fast. Do you want to explain that?
Yeah, it's the reason is explicitly due to GPS being used for cheap intercontinental ballistic missiles or just ballistic missiles in general. GPS receivers are shockingly good, like just consumer GPSs are shockingly good. And they're required to go under a certain speed or under a certain altitude. So like I said, most GPSs will just simply shut off to avoid any legal issues. But if you buy the right one from China, you can find one that will not shut off above a certain altitude because I propose that they don't bother to deal with the speed or the altitude, or you can buy a very expensive one from the United States that is more concerned with those ideas.
Keith K1OKS is asking, do you know when that started to happen?
I do not.
Oop, hang on a second. We'll go to Andy Shree, then I got a gentleman up here that's got a question.
I don't remember exactly, but it was maybe 20, 30 years ago. I had a wristwatch GPS, and on airplane flights, I was watching where we're going. I lost that thing, but more recent, like my phone, GPS, and so forth, they do what you said. They restrict.
That's great. Yeah, that's very cool.
Yeah. You have to remember that GPS is Department of Defense technology. So right from the moment of time it was introduced, the restrictions are already there. In fact, in the beginning, there was a civilian mode and it's called selective availability. Basically meant you got very lousy meters resolution. So these restrictions were there right by design, right from the beginning, and put into the ITAR export regulations.
Yeah, it's definitely, yeah, it's exactly, and it's an ITAR thing. There's also a great story, if any of you are interested. There's a theory going around. There was a ham who launched a Pico balloon around the exact same time that Joe Biden authorized F-22 fighter jet to intercept an unknown target slightly above, I believe it was near Anchorage, Alaska. And this ham claims that it was, in fact, his balloon that he sent up that was the unidentified target that was intercepted. And some people were claiming at the time that that was like a terrible thing to happen for the ham community, and that balloons are gonna have to stop after that. But thankfully, we've made it past that, and we've also made it past the Chinese spy balloon incident. If you make the right calls to the FAA, which I did, you can submit a ticket with them. You can get in touch, and you can let them know you're about to launch, and it's still permitted for us civilians to do.
Okay, got another question here.
Yeah, getting back to Armstrong, he also invented the regenerative receiver when he was, I think, a freshman at Columbia in about 1912. So he might have been a member of your club, or at least he probably knew about it.
Okay, looks like we got a Zoom question. Or is
No,
it yours?
I have a question.
Oh, you got your own. Fine.
Hey, thanks for the presentation. I actually lived in John Jay my freshman year, but I had no idea WKCR broadcasted out of it. I lived on the 6th floor, not the 11th floor, so not that.
Nice.
My question is, when you how did you get approval from the FAA to launch that high altitude balloon?
Yeah, that's a great question. I'm trying to think what I did. Uh, on the recommendation of my cousin Ben, I called the local office, and they redirected me to an email that I could email, or they actually redirected me to another office, and then they redirected me to an email. And it turns out that they contract out these documents to Leidos. So I was dealing with a Leidos person, and I had to fill out basically forms detailing our planned flight path, our launch time, our launch date, and there's a number of restrictions related to balloons. So, for example, like you cannot launch a payload over 6 pounds, just period, without some really crazy restrictions. Under 4 pounds, you need to have all these, above 4, you need to have certain mechanisms. So you have to give them this information, and then on the day of, you give them a call and you say, we're about to launch. What is funny is they ask for a predicted flight path, but that's basically impossible because it's just the wind. So I just gave them a rough guess of what I thought that they would think it would look good. I just made the path avoid any airports, and
Is that like the time that the president of the United States drew the path of the hurricane onto a map with a Sharpie? Speaking of the weather, the weather briefings are all also outsourced to Leidos as well.
And for our pilots, is that the same thing as a NOTAM, sort of?
So
that's exactly what it was.
Oh, okay.
They'll issue a NOTAM. So NOTAM is notice to air missions.
Okay.
So they'll issue a NOTAM for all the nearby airports, and then when you go do your pre-flight and you go check and print out or look on your iPad at all the NOTAMs, it'll say NOTAM balloon area here.
Can I share my screen? I actually have the NOTAM if you want to see
Oh
it.
yeah, show it, then I'll stand over here next to the next school.
I imagine that would be somewhat interesting. And I really appreciate they refer to me as Mr. Boxerman, and they call my friend, who's also a member, they just call her by her first name. So I got the professional. So here it is.
Hang on.
Here it is. The notice to air missions has been requested. And then you call a number, and then you provide the launch site information, nearest airport, and you can give them this number. And I provided, here's the document here, with the estimated information, and here's the flight path. I did not make this document. They put this together. I don't know who takes care of that, but they sent me this, so it was pretty cool.
All right, got another question here for you.
Hi, this is Daryl. Excellent presentation, and call sign is KI6LDM. Maybe this is a silly question. So as noted, are they or the Leidos, are they the same people that provide the air mission weather reports? Like when you are preparing to fly, the tower will say, "Do you have Foxtrot?" And you'll say, "We have Foxtrot," or "We have Romeo." Oh, that's ATIS. Okay. Okay. All right. Was just curious. This is excellent. Thank you for doing this. This is great. I love the history too.
Yeah, I'm glad. I'm excited to come in person. I can't wait to make it up.
All right. Any other questions here or on Zoom? Okay, Jacob, thank you so much.
Yeah, I'm really sorry I couldn't be in person, but thank you so much for listening. And again, I can't wait to make it in person. Maybe I can bring some toys or something. It'd be great.
Cool, no problem. All right, I'm going to throw it back over to Bob. You're more than welcome to stick around, Jacob, but if you can't, we understand.
Yep. That was, yeah, it was a wonderful presentation. I really, really enjoyed it. The history was great. The technology was great. It's inspiring me to launch something. I'm not sure if I'll get around to it soon, but it sounds like it's a lot of fun. Near an airport. Yeah, I'll plan to have it miss all the airports.